In this video, I just wanted to take a couple minutes to explain how to do this activity. Uh, that's the summative part of the final piece for topic 2.6. Let me get this highlight thing off. I don't know how to do it. All right, no big deal. So in topic 2.6, the main goal is one, just to understand the structure of DNA. And number two, quickly compare DNA and a molecule of RNA. So I think this does a really nice job of doing those two things. So it could be a little confusing as you're working through this. So let's just make sure that we understand how the assignment looks. So when you click on this link, this is what the page will look like when you get there. It's DNAi.org, DNAi Interactive, and there's a bunch of different menus here on the left-hand side. And according to the according to the instructions, it asks you to click on code. And then after you click on code, we're going to click on finding the structure. And here there are a couple more choices on the top here. So the problem, the players, pieces of the puzzle, and putting it together. For us, we're going to focus on the problem. And then in the second part, we're going to talk about putting it together. So if we click on problem, it has a brief introduction about like how the actual molecule of DNA was found and how it was found by this scientist named Mishner. So you read through this little paragraph here and you click to the second one, and there's two more very tiny paragraphs. And from that, you should have enough information to answer questions 1, 2, and 3. So that's step 1. For step 2 of this assignment, it says that we're going to select putting it together, and then we're going to select this thing called the base pair interactive. So this is where it gets a bit more confusing. So here we have putting it together. So I will click on that. And then down here, I have two choices. The DNA double helix, which is kind of cool, just to see like how they assembled, excuse me, how they assembled the molecule of DNA through modeling. It's actually James Watson explaining it. But the one for this part of the assignment is we're going to do this base pairing interactive. So you click on that, and you have like a blank little table with some pieces here, and we're going to join them together. So what I want you to understand from this activity is to see like how the orientation of these bases, adenine, guanine, thymine, and cytosine, makes it form into this helix. Also, I want you to see how the hydrogen bonds are formed. If you remember way back when we were talking about amino acids and proteins, the amino acids will form hydrogen bonds with each other to form those two secondary structures called a beta pleated sheet or an alpha helix. And those occur between oxygen and hydrogen, and also nitrogen and hydrogen. And the same thing will happen here. So to see this better, it works well when you show the atoms. So I'll be able to hopefully describe that a little bit better when I put these in here. So I'm going to grab a molecule of adenine. Actually, I'm going to put it, whoops, let me just for sake of better explanation, I'm going to put adenine on the left. And then which one of these bind with adenine? I hope you said thymine. And thymine on the right-hand side. And we're going to join them together. But the best way to join them together is to show their atoms. So we can see the interactions between the hydrogens and the oxygens, and also the hydrogens and the nitrogens. So what you need to do is you need to join them together. So if I hit join right now, nope, they're not going to go together because I don't have them rotated in the way they should be. So maybe if I rotate adenine this way, there I've got a hydrogen, a nitrogen, another hydrogen here. And maybe if I rotate thymine this way, that's a hydrogen-hydrogen. That's probably not going to work. But we can see if it does. Nope. Let me rotate it again. Ooh, maybe the oxygen to the hydrogen and the hydrogen to the nitrogen. Maybe this will connect it. Yay, it does, right? This is okay. It's upside down. So I just wanted to show you a couple things how you can do this. So it is possible to have the adenine on this side, right? And the thymine on this side. Whoops. Not sure why they're so close together. Anyway, so I can rotate them to have the same orientation between the bases to get those molecules to interact. So I think this is the way we had it before. Let's see. There we go, right? And we formed those hydrogen bonds. How many hydrogen bonds? 1, 2. So that's how you do this first part. I'm going to let you do the same thing with cytosine and guanine. So once you get there, then you're going to flip to the next slide, which I don't know if it's going to let me do that. It won't. Anyway, where you go to the next slide, and that's where you're going to go through and you're going to add the sugar phosphates onto the bases, just so you could see the sugar phosphate backbone on this side, and then the sugar phosphate backbone on the other side, and pay close attention to the orientations of the sugar, right? The deoxyribose. They should be what we call anti-parallel. So that's the assignment. So you're going to go through this. It asks you to identify the 4 bases and pair them up. The hydrogen bonds, I think you guys all know how to read, so I probably don't need to go through these. And then in the last part here, describe how the sugar phosphate backbones are different, looking at that deoxyribose specifically. Okay, so that is the final assignment for topic 2.6. And then just answer the questions right on this worksheet and upload it to Google Classroom.